Alright, so hopefully before starting this video you've at least read and looked over this. In fact, you might even be able to answer some of these questions without my explanation at all. But let me just run through this. Direct variation are the simplest type of linear equations where we're actually talking about a y equals x kind of equation. They're basically a linear equation with no y-intercept. They always go through the origin. Alright, so it's defined as y equals some number times x, and we just conventionally call that k when we don't know what the number is. Alright, this number k, which is a number in all our problems, or we find it to be a number, is called the constant of variation. Alright, that tells us how much y changes when we change an x. Alright, so if we have something like this, our constant of variation here is the -2. And if we look at this line, our slope is down 2 over 1. So our slope is -2. In fact, that always occurs. Alright, the slope always equals the constant of variation. That's an of, sorry. Alright, so that tells us that if we change x by 1 unit, if we increase x by 1 unit, y decreases by -2. If we were to increase x by 2 units, y would decrease by 2 times -2 is -4 units. Alright, that's what our that's why we call it the constant of variation, or constant of proportionality. So for here, what's the constant of variation? Good, it's a 3/2. And the slope of the line is, again, 3/2, right? +3 and a +2 for our run. So our rise over run is 3 over 2. So that is our slope of the line. So what point does it always cross? Well, you notice there's no plus term here, so it always goes through the point 0, 0. So it always goes through the origin, the point 0, 0. That's a helpful thing when we're trying to come up with our equation. So, how do we graph them? Simple. First, we start with the point 0, 0. If I tell you it's a direct variation equation, you know that this point is automatically on the line. So graph it right away, no problem. Secondly, what you're going to do is use the slope to graph a second point. Alright, so here my slope is 3. I like to write it as a fraction, so I really think of rise over run. So that's like y equals 3 over 1 times x. So my rise is 3, my run is 1. Right, you guys know how to graph these now. It's rise of 3, run 1. There is my new point. So rise of 3, run 1, and my point 0, 0, my point 1, 3, there's my line. And I can even continue the pattern backwards if I want to. So if I went up 1 and right 3, then I can go down 1 and back 3, and that will continue my linear pattern. Alright, so if I want to get a good looking line, well, as good as I can do with this pen. So again, same deal. How do we graph it? We just graph the origin. Alright, 0, 0 is on our line, and then we get our next point. Now, remember, when I have a negative fraction, I told you guys to write it like a -3 over 4. Just always make the top number on your fraction negative. If you do that consistently, then you won't accidentally have wrong minus signs later in your work. So that tells us we go rise over run is down 3 and right 4. So down 3, right 4 gives us this point. If I continue the pattern backwards, you look how that's moving, it's going to be up 3 and back 4. And then there's our line. There you go. That's your line. That's graphing direct variation equations. So there's several sides to this, but there is a U-try on that particular concept. So your first couple is these. Alright, jot down any questions or notes you may have. Alright, now for writing and solving direct variation equations. So we want to write one. So the first thing we're going to do is we need to get the slope. Because a direct variation equation looks like y equals kx, right? And this is going to be our slope. So, first thing I want to find is the slope. Now I know that they always have the point 0, 0 on a direct variation equation. So that can be my x1 and y1. And now I need a second point. Well, a second point would be y equals 30 and x equals 5. So that gives me the point 5, 30, right? And that will be my x2, y2. Now this works out to be really easy math because I'm just doing 30 minus 0, y2 minus y1, over x2 minus x1, 5 minus 0. And because I'm always going to be using these zeros, because the origin is one of my points, the slope just works out to be 30 over 5, which equals 6. Okay, so anytime they give you the y and the x and tell you it's direct variation, you know that your slope is just going to be the y over the x, and then simplify it. So we did that, and we get y equals 6x. That is our direct variation equation here. Now, if I find x when y equals 18, so like I said before, whenever you're doing a problem like this, just write the formula, y equals 6 times x, and plug in the numbers you have. So you have y equals 18. So that gives you 18 equals 6x. Divide both sides by 6, and you get 3 equals x. Solved. Great. So I think that's the last part of this topic. You also have a you-try problem, just one problem to try on that. Alright, and good luck. If you have any problems, make sure you jot down your questions, and I will see you next class. Finally, now we're going to talk about the applications of some of these direct variations. So the most common one would be the distance equals rate times time formula. So this is a velocity equation as well. So this would apply to this problem here. So if you drove 225 miles, that's your distance. Your time was 5 hours, and we want to know the rate. So you just plug in the numbers. So we have 225 equals the rate times 5. Solving for the rate, we would get 225 divided by 5 is 45, so 45 equals r. Now we wanted the equation, right? It's a direct variation equation. So now that we found r, we actually write out the equation. So it would be distance equals 45 t. So for every 1 hour you go 45 miles. So your rate is 45 miles per hour. So here the total cost C of bulk jelly beans is $4.49. This is direct variation because right, if you buy 0 jelly beans, the cost is 0. So it goes through the origin. And then for each 1 pound, so the change in cost over the change in pounds is going to be $4.49 per 1 pound. So there's our slope. That gives us one baby step further to get the equation. Now if they give you the variables C and P, use those in your equation. So the cost is 4.49 times the number of pounds. So there's our equation. To graph it at the right, 0 pounds, 0 cost. 1 pound, 4.49. It's just below that. 2 pounds would be 8.98. Or no, yeah. And then 3 would be 13.47, and 4 pounds would be 17.96. And you can see that it continues in a linear fashion. We don't graph a negative here because that doesn't actually make sense. To find the cost of 3/4 of a pound, you would just do the cost equals 4.49 times 3/4. So that equals 336 3.367, so it's dollars and cents. We're going to round to the nearest hundredth, so that's $3.37. Alright, and then you have a U-try that's kind of similar to that. Alright, have a great day. Any questions, write them down in the margins, and I will see you next class.